So welcome to today's exciting conversation about how to write ideal test cases for your React apps. We are going to be getting into all sorts of exciting stuff, covering that topic at large, getting into some actual live coding, live demoing to see this in action. And we'll be kicking off with that in just a moment. As a quick introduction, my name is Jacob Smith. I'm the community director for Altimetrik Collider, and I'm joined here by my right hand, Ryan Robinson, who's somewhere on your screen. Ryan, say hi to the people.
Hello, people.
And for quick context, Altimetrik Collider is a digital business catalyst. So it's all about smashing together the brightest minds in technology and in business to unleash an explosion of innovation. So we're all about bringing together tech innovators to talk about that intersection of technology and business, and to see how to solve business challenges more efficiently using technology. So as such, we are excited here today to be joined by Shiva Bhaggan, one of Altimetrik's engineers, who is working full-time at Ford on a number of exciting initiatives, who can explain the topic in a bit more detail. And Shiva, if you wouldn't mind just speaking just quickly a bit more about your background before kicking off as well.
Sure. Thank you very much, Jacob and Ryan. So hi, everyone. Thank you very much for being here. So my name is Shiva Bhaggan, and I'm a full stack developer. I've been working in the backend most of the time with Node.js, Express framework, and as well as Java with Spring Boot. And on the front end, I've been using a lot of Angular applications, React applications. I've tried few as well. So it's like initially I was more as a full stack JavaScript developer, but recently I've been working professionally as well with Java and Spring Boot. So that is it when it comes to my background. Today we'll be diving a little bit deeper into how we can write test cases for front-end application, because usually we only write back-end test cases. I mean, that's how I used to write code. And then when we realized that front-end is actually as essential as back-end test case as well, because a lot of things can go wrong, right, when you're going in production. So we will be talking about test cases generally and test cases more in React, and focus on how the implementation actually is meant to be, okay? So I'll be sharing my screens. I have some slides, not a lot, but just want to go over. Let me just quickly share my screen. Can you see my? You can see my screen, right? Right. Okay. So perfect. We will be starting with just basic what a test case is. Why are test case important for your application? And one really important topic is what we are going to discuss about what is like what to consider before writing production code, because I think that's really important before you move forward when you're writing test cases, as well as implementing your actual code. And then we will be heading over what tools we can use to write test cases, and what tools I used in my demo project, which I will be doing at the end of this slide presentation. And then we'll be talking about different strategies for writing front-end test cases. So we'll be going over those topics. Let's first start with what a test case exactly is, right? So, I mean, I know most of you are familiar with a test case, maybe not as much as in the front end, might be a little bit different. But when it comes to the definition, we all know that it's a process used to identify the correctness, the completeness, and as well as the quality of your developed software code, right? So basically what happens there is that while you're writing test cases, it includes a set of activities conducted, right, with the intent of finding errors, especially in your software, so that it could be corrected before the product is released in production. So that is the main reason why we are writing test cases. And as a summary, right, just testing is just an activity to check whether the software system is defect-free, right? That's what you want to make sure before you move it to higher environments, especially when you're going to production. So that is when it comes to a test case, super simple and easy. And why actually are test cases important, right? That's the question most of the people ask as well before writing test cases. I mean, even when I started developing front-end applications, I was always curious about why do we actually need test case for the front end, right? It's pretty straightforward. But when you go into projects and you'll start realizing that, not everything is as smooth as they seem to be in the beginning. When things becomes really complex, your system becomes really big and huge. That's when you're actually going, that's actually the point where you're going to realize, hey, maybe I need to do something with my code before moving it forward, right? Before making sure that everything works as expected. So why are test cases important is what I feel that developers can use test cases as a documentation over their code. That's the first thing, which might not be the primary use case of writing test cases, but it's super important because when you are having new developers coming into your team and they probably want to know how a component works in your front end or how a particular method or function works in your back end, you can easily pass them your test cases, and you can tell them, hey, this is what my test cases are, and they can easily go over your edge cases, your special cases, and they can see the normal behavior of your piece of code, right? Whether it's a method, whether it's a component in the front end, doesn't matter as long as you're writing test cases. So that's one. The second, which I feel is actually really important, is that developers can increase the quality of their production code by adding numerous of test codes or numerous of test cases, basically. And we are also going to see what type or level of test cases we can write in order to make sure that we are having a good quality, or at least have that approach of um, writing quality code right before you move forward. And the third point basically is a conclusion of point one and point two, is like you want to avoid big losses, right? I I intentionally added this meme inside the slide here because I just wanted to give you a quick, I just want to tell you a quick story about Ariana. I'm not sure if you all are familiar with Ariana, but Ariana was like a rocket that was developed like uh 20 or 25 years ago. Like it was basically 1996 by the European Space Agency, and they developed this rocket for over 10 years, right? They spent a lot of time. Not only that, but they also spent a lot of money, right? That's obvious. And what happens is that when they went into the launch, the production, basically, is when they released this rocket, right? It went up for like a couple of kilometers, like 4 or 5 kilometers. It made like a flip, and then it blew up, right? And then people were really like starting to investigate on this issue, right? What actually went wrong? And then from the investigation report, they actually concluded that there was like a float parse from, I mean, there was a parse issue from flow to end. So it make a little flip and it blew up. So I mean, history is full of a lot of examples why writing test cases are important, right? Those are things you want to avoid. So that is one example. The second thing which I really feel is important before you write test cases is that as a developer, you want to make sure that what type of code or what type of use case you're going to implement, right? You first want to make sure what your end goal is before you start writing the code. I mean, it might be obvious, but I think I wanna put more into that, because when you're writing test cases, you're also consider what type of test case you're going to write. Okay, so we have like different test cases we can write. We can write unit test cases, we can write those integration test cases, and we can also write end-to-end test cases. So in this demo project, I have levels of unit test case and end-to-end test cases, which we'll go through and see how we can actually write those. There's another graph here. It's not really a graph, it's like a testing pyramid, which actually shows that the higher you go, the slower and more expensive it becomes. And down the line, you will be more faster and cheaper, right? And what that actually indicates is that when we are writing unit test cases, we can make sure, or we are actually sure, that they will run faster than the test cases. Like for instance, when you compare with end-to-end test cases, because they are more involved, they have more flows into it, so most probably, and it will also run a little bit slower than the unit tests, right? So what we most of the time follow in our projects is that we write a lot of unit test cases, right? A lot of unit test cases, bunch of integration test cases, and few end-to-end test cases. But I feel end-to-end test cases is something really important because it covers a whole block of flow, right? But unit tests, again, so they have all their importance level, which we will see more into the demo and how we can basically implement there in our project, right? Okay, so I'll move on to the second last slide, which includes the tools that we are going to use in this session. One is Jest. So Jest we'll be using to maybe mock. We'll be talking a little bit about mocking our REST calls from our React applications. And we will also use Cypress. So Cypress is another tool that can help us write end-to-end test cases. It can also use to get Cypress can also be used to generate reports for you to make sure which component are tested on how many percentage. So it gives you a brief overview of how your code basically is with respect to test coverage, okay? And then I think it's time for demo. I had to come up with an idea what I'm going to build that is easily testable and demonstrate some concept about testing. And the only thing my brain could come up with is let's make a simple application that basically calculates your cryptocurrencies into US dollar worth, right? This is super simple, but you'll have a clear idea of what's happening. And you know how demo works, so hopefully this goes well. So yeah, I think that's it with respect to my slides. Let's jump into my React app.
And quickly before you kick off, Shiva, I just want to reiterate, if you have any questions as Shiva is going, just please feel free to drop them in the chat and we'll work those in as we go. So drop questions in the chat and we'll work them in.
Perfect. Thank you very much. Okay, so before I navigate into the project structure and the code itself, I think it's important for us all to understand what actually this application is doing. So I'll just give a demo on this application itself, on its use case basically. So I'll just start my application, npm start. Okay, so I use Material UI. Just I just didn't want to spend a lot of time designing the buttons and the components and all. So I just use Material UI, which is open source and it's free. So I used a navbar, which is one component, and I put all this content into one component just for the simplicity, okay? So what it does basically is I created 3 cards. One is Bitcoin, Ethereum, Dogecoin, obviously. All those 3 are here. And they all have the ability to take in a value. And this value basically represents the user's worth, okay? With respect to the coin, to that particular coin. So let's say, I'll just take some random numbers. So let's say a user is trying to calculate their net worth at this particular time. They will probably start with Bitcoin. And then let's say the user has 0.004 coins of Bitcoin. And Ethereum, let's say they have like 0.4. And let's say for Dogecoin, he might probably have a lot because it's not that expensive. So let's say they got 10,000 coins of Dogecoin, right? Okay. So the second thing the user will probably do is they will fetch the rates. Now what this does, right? This fetch rates. Fetch rates basically makes a REST call to a Coinbase API that returns that particular coin value, okay? So if you want to see that, I can open the DevTools. I'll just go to network and I'll just refetch it. So you can see I'm making 3 REST calls. One is for BTC, one is for ETH, and one is for Doge. And you can see how the data comes in. It has like a JSON response, whereas one of the values is USD. So it will be somewhere here. So here, so it's data.rates and then .USD, and that will give you the value of that particular coin, okay? And that's how I read it in my React application, and I just render it inside this fab. So this circle oval thing is called a fab in Material UI. And now now that's the last step for the user. I mean, the second last step basically, because he still need to calculate the work, right? So here you can see if the user sells all his cryptocurrencies, there he will be having around 2,600 US dollars. Okay, so that's it. Super easy and super simple. It's not complex. So we will be writing test cases for our navbar. We will be writing test cases for this content component. Well, I did this intentionally because a navbar is just the static data, right? It's just taking probably a label and then it renders whatever is inside that label. The second component, which is the content component, that is a little bit more evolved because it requires a REST API call. It requires some user input. It requires a button that does a simple arithmetic operation. And then again, it will calculate it for you, right? So that is a little bit more complex than a navbar. So let's start with the project structure before we go in the actual test case. Okay. So if you're familiar with React, you know we follow a convention where we have a folder components. We add our components in there. So I have a content and I have a navbar, right? So the navbar represents the upper side of the screen, and the content represents all those cards with the buttons and the fabs and the inputs, okay? The text inputs. Okay, that is those two components I have in this project, and I render them obviously from my app.js, right? So here you can see I'm rendering a navbar which takes in a label, and the label takes, I mean, the label attribute, you can specify whatever you want to specify in order to render on your navbar. And in this case, I just added my crypto portfolio, right? Super easy. And then I have a box. So again, a box is, you know, from Material UI. It's not my custom component, so I just use it because why not? And then I use my spacing grid. Okay. Now this spacing grid is whatever I have in my content. Okay. My content is my only content component that consists of those cards and buttons and text fields and all. So that is the project. That is how it works. That is how it's structured. Now, let's jump a little bit into one of the components. So let's start with the navbar. So the navbar, I'm importing everything from Material UI because I did not want to spend a lot of time designing the buttons and the text fields. But I want to put some more focus into the return block of this component, right? So you can see this return block has some Material UI components, and most importantly, it has a typography. Okay, this typography, in the body of the typography, we are basically injecting the label, which is coming in as a property input, right? So I'm rendering this dance app bar from my app.js. I'm providing my crypto value, and this dance app bar, when it's rendered, it will have that my crypto value, and it will be at the time in the DOM element, it will have this my crypto value. Okay, that's super simple. So because this is, I mean, this is intentionally again because it's a simple static component. I mean, static in terms of will not be changing a lot. This is basically based on the design and whatever the requirement is of the project. But why I did this is because I wanted to simulate some test cases on this, okay? On something that does not really frequently change. So let's see how we can do that. So in my case, what I do or what I usually do is I create a folder under each component, and I call it underscore underscore test underscore underscore, just following some conventions. Okay. So in that folder, what I have, okay, I have a snapshot folder and I have dance app bar.test.js. So you can see the name of my test file is exactly the same as my component. The only thing that is a little bit different is the extension, because here we are specifying that this is a test file for this component. Okay. So what I'll do, I will open this test file side by side, and I will open the test case I wrote. So what I do here is I write a simple unit test. how do I write this simple unit test? I just want to make sure that whoever uses this component and inputs a label, whether it's my crypto portfolio, whether it's some other text data, I just want to make sure that whenever this component gets rendered, it has the correct label input, right? Whatever is in the label, I want to make sure it is inside this typography. So what I do for that, I add a data test ID and I call it header. Why I do like such a thing, right? Why do I need this data test ID? Because I need to refer to this typography from my test file. Okay, because how otherwise will you know which element to target in order to assert it on, or make sure that that text is indeed rendered inside that typography. Okay, so I just go and add some header, or you can, this is just a variable name, right? So you can do what you can add it whatever you want, but it should make sense. So because it's kind of a header kind of element, so I just added header. So let's see that, let's go back to the test case. What I do is I call this render method, right? So this render method I'm getting from testing library React. Okay, so I'm like destructuring that render from this testing library, and I render that particular component in my test case. Okay, and I render it with a label saying my crypto portfolio. This is just the test case, so you can put whatever you want inside this label. The only thing you want to make sure is that upon asserting, when I say assert, then I most of the time refer to expect something to have text content, right? That's the test case you are going to test on. So what I'm trying to say here is render this component for me, and this render method will return you an object, but I only need get by test ID function or method, right? So I destruct that method from the return type of render. And what I do, I execute this function by inputting the data test ID. So you remember, right? We talked about header. So I use this header inside my data test ID. I inject it here, and now I expect this guy, which basically represents this typography, right, to have text content my crypto portfolio, because that's what I rendered the component on, right? And that is a simple unit test, right? See how easy it is? And I just put some description for it, like saying render navbar correctly with correct input label, right? So other developers comes in, new developers comes in, they know exactly, hey, this dance app bar, what it does, it renders the navbar correctly with correct input. So most probably the test case is based on the label is exactly what is getting rendered at the time of this component, right? As to be text. Okay, so that is a simple test case. That's super simple, super easy, but it's powerful, right? Because you make sure you cover that particular flow. Now, another cool thing is snapshot testing. So what is snapshot testing? See, a lot of changes will be there in your project, that's for sure. You want to make sure that you track those changes, right? You want to make sure that you are intentionally modifying a particular part of your JS file. So let's go back to Dance app bar, and let's okay, before I do that, let me just quickly delete this folder, because this folder is getting generated by the renderer, by this test case. So I use renderer. Now, what is renderer? Renderer is another dependency I installed. So this is react test renderer. What this does, basically, it uses the component you're trying to render, right? So it is a create method, and inside the create method, you provide this dance app bar label, right? And now what this will do, basically, it will return a tree. Now, a tree, I'll show you how that tree looks like, but what you're trying to do, you're expecting on your assertion level, you're saying, expect this tree to match snapshot. Since I deleted that snapshot, it will create that tree for me. So let me open a second terminal and let me run npm run test. So you can see, right? I'm running my test cases. It said one snapshot written, and you can see this folder got created. So if I open this folder, you can see it basically rendered that component with all the class names and everything on top of it. But you can also see that since my test case I rendered with my crypto portfolio, it rendered exactly whatever was in my label, right? So you can see it added like this. This is the initial time, the first time you're going to write a component and you're going to create a snapshot testing for it. This is how it will create. Now, snapshot folder is also something you're going to commit. You're also going to keep track of that. And why? Now you will see the point of this. See, let's say after a couple of months or years or maybe even days, another developer comes in and he just decide that maybe my crypto portfolio is something, yeah, okay, it's nice, but we want to have another static data in front of this. Let's say just for the purpose of testing, I'll just write hi. I mean, it might be that you're creating a naming kind of application. So maybe this will be a name. So you can say hi, for instance, my name, hi Shiva. And then you want to make sure hi is also always there, right? See how I changed this and my test case, my entire suite ran again, and you can see how this failed, right? It immediately tells me that, hey, this snapshot is failing because it did not match the initial snapshot, right? And it also gives you all the data saying, hey, see, this high was extra. Is this something you want? Is this something intentionally, modified? So here you have two options, right? You can either realize that, hey, I made a mistake. This is not how it should be. I can just get rid of it, and the test case will pass again, right? But it can also be that this is maybe an extra feature you got from the business and you need to add in your project, right? So what you can do in that case, you can see there is something called press W to show more, right? So let me go ahead and press W, and you can see it's giving you the option, press U to update failing snapshot. So if I press U at this time, what it will do, it will basically um, add this high for me in that snapshot. So you can see how that works. So let me press U. It will add this high, run the test case again, and it will also mention that one snapshot updated. So if I open this dense app bar in the snapshot, you can see that high was there, right? So this is how you will always keep track and make sure that no one goes and, you know, um, changes something without having an intention of changing something. So that is why we can have snapshot. It's like creating a picture or creating a screenshot of that UI piece and always having it with you. And every time when you run your test case, it will test it against that snapshot. So it's super easy and super powerful, right? Because you will never lose track of whatever you are trying to change. So that is it when it comes to our navbar. Let's now jump into our other component, which is the content component. So if I go back here, so we saw how we wrote test cases for our navbar. Let's see how we write test cases for our dynamic components. And when I say dynamic, I mean dynamic data, right? Is coming in. Okay, so how we do that, right? Let me close this and let me open the spacing grid, and let me just give a brief overview of what's happening here. Again, I'm importing a bunch of components from Material UI. I get some pictures which I just showed up here, and also Material UI VAP. I have a text field from Material UI, and Axios. I'm not sure if you all are familiar with Axios, but Axios is just a dependency that helps you to make a REST API call from your client. Okay. In this case, from my React app, I will be able to make a REST call. So let me go to the return. What it has, so I have papers, right? So you can see those are papers from Material UI, and this basically represents one card. And in that one card, I have an image, which is that Bitcoin image. I have a text that says Bitcoin. I have the value of Bitcoin, which is a data that I will be injecting when I press on fetch rates, because if I refresh this page, you can see it's 0 because I'm reading this value, which is again from use state, and I have an initial value of 0. So that's also super simple. I created that same thing 2 more times for other other type of cryptos. And I basically just, just do the same, right? Read Ethereum value, and I also read Dogecoin value. Okay, now this button, right? Fetch rates. So if I go to this button, fetch rates, what it does, it just I have an on-click event handler that basically calls this method. Now, what does this method do for us, right? So as I mentioned, Axios is a dependency to help make you a REST call. I have an API from the website, from Coinbase. It's free. You can use it, and no API key needed. Nothing. It's just open, and you just specify the currency you're trying to get data for, and that's what I'm doing here. So when I press on that button, I will make a call to this API, and I read the data as I showed you in the developer tools, data rates, and I get the US dollar. I read that US dollar and I add it inside my set Bitcoin value, right? Which is a setter for my use state variable. Same thing I do for Ethereum and Dogecoin. Pretty simple and straightforward. Once that data is there, React will just reflect into your fab, right? So if I press it, it makes the call, reads the data, put it in the variable, and that's how I read it back. And the last thing, calculate my word. So if I go to that button, calculate my word, this one, what it does on click, it calls this calculate method. So this calculate method, what it does, it will just take the BTC times the Bitcoin value. Now, this BTC basically is another block of use state variables I created. And this basically holds the value, whatever I'm inputting inside the text fields. So you can see how easy this now is. So I just see BTC, which is like say 1. So it will be 1 times the Bitcoin value, which is the call I made from the API. Now I know that I have the data. So I will again, add Ethereum and Doge. Okay, super simple. So that is the implementation of this particular component. So now, how do we write test cases for a component that makes an API call, right? That's the question now. So let's see how we do that. So the first thing you want to make sure is you have a way of mocking those calls, because when you're writing when you're writing unit test cases, you want to externalize all your other services. You want to focus on your unit. That is how more accurate that is, the better it is, right? Because you will not be taking code from other developers into consideration. So the first thing you want to make sure is you have a way to mock those Axios calls, right? So the way I do that is I create another folder into my source, which I I named it again with convention underscore underscore mocks underscore underscore, and I give it the same name as my Axios dependency, right? Axios.js. So here I export one function, the get function, because obviously I only use get. So you can see, right? I only use the get method. So I don't need to mock, post, and delete and all those kind of methods unless you need it again. So what I do here, I call this just function mock resolve value, right? So what this does, it basically initializes that get mock function for you. And in this case, we are saying return data for me, which is an empty object. Now, this is kind of an initialization, is how I see it. But when you're going to write your test case, you want to override this because you want to put your mock value in it, right? So what I do is if I go back to my test case of space and grid, again, it has the same name with a test extension. So what I do, I create this method. I say mock Axios get and return. So what I say is that take a value. Let's say I'm just getting a value, like let's say if I make a call to Bitcoin Coinbase. So if I make a call to this endpoint, I'm mocking the value to be returned of whatever I'm actually injecting here. So you will see this into more details, but this is just how the method works, right? So I get the value, and this is how I structure my data. Rates.USD, because this is the same way I'm reading my data in my implementation code, right? You can see data.rates.USD. So you want to make sure that this is the same data structure as whatever you are mocking. Okay, so that is how we mock. Now let's see, before we go into the mock, I also have I have small unit tests for this little bit more complex component as well. So what I do here, right? I say initially without any access call. I want to make sure that whenever the user navigates to my web application, I want to make sure that everything is set to 0 because the user did not perform an action by clicking on fetch rates, right? So we want to make sure that $0 is the initial value that gets rendered upon navigating to your website. So how do we do that, right? It's the same thing. We will use the render method again from testing library React. And we are basically rendering our spacing grid, which is that component we are testing on as a unit. And again, we will get by ID. So I have data test ID inside here. So I can show you that. Okay, so I have a data test ID and I refer back in my test case, get by test ID and expect this guy to have text content initial value, right? So you can see this is $0 and that's exactly what we are rendering initially. And we are expecting this get test by ID to have that text content. That's one. Again, I'm doing the same thing for all the other paper cards. So I'm not going over that right now. But let's talk now about the mocking, right? So the mocking part is really important. As you know that whenever the user navigates to the website and he presses on fetch rates, right? I just discussed that whenever he presses on fetch rates, what are we actually executing is this method, right? This get rates of my cryptos. So you can see in this method, the way how it is designed right now, you can easily extract that we are making 3 API calls, right? That is why I need to mock 3 times, because if I mock it only 1 time, for this one, it will give you an undefined value because it will not be able to read those kind of things. Remember, because we have data as an empty object, right? So you want to make sure you mock it as many times as the actual implementation code. So since we are calling the Coinbase API 3 times, we'll be mocking it 3 times the um, with the values, right? So the first one is Bitcoin because that is how it is implemented. I'm calling Bitcoin first, then Ethereum, and then Dogecoin, right? So this is how for testing purpose, I just added some random values. Now what I do is I do the same thing. I say render this component, right? The spacing grid. After rendering it, we are actually extracting now, instead of a fab or just checking a text content, we are extracting a more evolved thing. We are basically extracting a button. Why? Because we want to press, right? We want to click. Only after the user clicks on this particular button, the API call is actually going to be made, right? So what I do is I say const button, I just initialize a variable, and I say it's equal to that get by test ID, which I destructed from the render, and I pass in the fetch button. Again, fetch button is nothing complex. I just named it fetch button. It's up to your design how you want to name your IDs and all. Now that I have the button, you can now click on it. How do you do that, right? That's super nice. See, if I'm importing fire event from testing library React, what this fire event will do, it will give me the ability to click on a button, for instance, right? In this case, it's a button. So I click on this button, and those are the 3 steps required to actually execute that method. So if you are familiar with writing backend test cases when you're testing a method, at some point in time you will execute that method, right? That service method or whatever method it is, you will be executing it. But before that, you will have your mocks ready, your expected values ready. The same way we are doing it here. We are mocking it, whatever is needed for preparation. When we are done, because that's the only thing we need for now, we will execute the method by getting the button and firing an event as a click on a button. Now that we know that we clicked on the button like this, we clicked on it, we know that this get rates of my cryptos as an asynchronous function, right? So you want to make sure that you are not just, getting the value, but you are getting the value in a callback that relies within a wait for. So this wait for is, again, you need to import from testing library because you are testing on asynchronous methods, right? And those fields are getting filled in whenever that API call is made. Again, in this test case, we are not making an actual call to that Coinbase API. We are mocking it, right? So whenever the code reaches at this point, actions.get, it will basically return for you, the first time it will return you this data. So I have 50,400 US dollars inside Bitcoin as a value. So that will come inside here and it will return you this data structure. And because your actual code is reading it like that only, your test case will also have that content. So whenever you do I'm getting that value inside a variable because I just fetch it into a variable. I use this resolve web for Bitcoin to assert, to expect it on, and make sure that, hey, since I'm returning 50,400,80, I want to make sure that the text content is in this format, right? Because that is what I'm printing, right? A dollar format with a space, and same for Ethereum and same for Dogecoin. And that's exactly what I'm doing. But I'm doing it with the help of mock, right? Because I don't want to make an actual call since I'm writing unit test. Now, when are you going to make the actual call, in which type or level of test cases? That is something you will most probably do in an end-to-end test. So that is it when it comes to component level testing, which is more of a unit test. We have seen snapshot testing as well, right? Or we saw to make sure you're keeping track of those changes in your component. Now with that, let's move to a more higher level of testing, right? Which is the end-to-end test case. So to write end-to-end test cases, you will need another library called Cypress. So if I move to my package JSON, you can see I have Cypress. I have also other Cypress dependencies for code coverage and instrumenting my code. So I'll be going over that as well now we're going to talk about that end-to-end test. So how do I write end-to-end test cases, right? So once you install Cypress, it will add a folder for you in the root of your project, which is here, Cypress, and it will give you all those folders. Now in your integration, you will most probably see two more spec.js files. You can just remove it because it comes as a default. You don't need it probably. For me, I did not need that, so I removed it, and I created my own spec file. So what this spec file will do, it will basically require you to write a flow in order to run your end-to-end test. So what is this end-to-end test I just wrote here is exactly what we did. In my test case, I'm saying navigate to our homepage. So what this test case will do, it will literally go to the homepage. It will visit this, because it's running on localhost 3000, so it will visit this on this URL. It will get the button, basically this fetch rates, and it will click it for me. So you will see when the test will run, you will see everything happening automatically. So it will click it for you, and now it will fill in the amount of coins, because that is a flow, right? If you're writing a banking app and you want to write an end-to-end test case, most probably you want to cover this flow. The user logs in, he makes sure he has sufficient funds, and maybe he want to make a transaction. So in your test case, you will check whether he has sufficient funds, and you will make the actual transaction. After that, you will most probably check whether the amount was subtracted from your balance, right? Or from your current status. So that is a valid end-to-end test flow. Same thing we are doing here, right? We are filling in the fields. So those fields are going to be filled in by the test cases. And then it will press on this calculate button. Now when this calculate button, is pressed, we will be getting all the data inside this fab as to be your net worth in dollars. And now the last thing what you want to do is you want to verify. You want to make sure that whatever data is here is exactly the same data as what I expect And what you expect is just a simple arithmetic operation, which is X time your Bitcoin, Y time your Ethereum, and Doge, Z time your Dogecoins, and the sum of those, right? That's what you expect. And that's exactly the same thing we are doing here. Before I head into the implementation of my end-to-end test, let me just run it so you can have a better idea of what's going on exactly. So what I'll do, I did not only install the Cypress library, but I also added a script, right? I added the script. So if I say npm run Cypress, right? If I say npm run Cypress, what happens actually is it will open an application for me. So this is Cypress, and Cypress reads everything, whatever is um, in your integration folder. So in my integration folder, I have crypto portfolio underscore spec.js. So you can see here in my Cypress, I have crypto portfolio underscore spec.js. So if I press on this, so let's do that. You can also pick up a browser to automate this test for you, because it will literally do everything for you, whatever you have specified inside this spec folder or file. So in this case, I'll just use Electron. You can use any browser, it's fine. So see, look at what's happening, right? It will visit the website. I'm not doing anything, right? It's doing automatically. It will click on the button, it will fill in those fields for me, and it will calculate the work. And as you see on the left side, point number 19, it also asserts for me that 4,253.89 is equal to the value inside this VAP. Now, another nice thing of Cypress is that you can time travel. You can go back and you can see, hey, before inserting a value, or maybe before making the call, see, you can see the calls. You can even inspect and you can see all the data in each and every step, right? So if I go to console, and you can see how my console is changing, right? So you can literally time travel. So this will help you, when you want to debug something that's going wrong and you don't have an idea of what's going on, right? So that is Cypress. Super easy, super interactive, because it's like a human is interacting with the UI, but it's actually just a test case, right? So it will fill in everything, make sure that the data is returned, assert it for you. And this is simple, but if you have a big application, which will be most likely the case, imagine how nice this is, because it will identify all the issues if you change something, right? Maybe you change something in the arithmetic operation. Now, this test case will identify that for you, and you can always, migrate those kind of tests as well in your pipeline before you are even deploying, or maybe even before you're merging to master. You can, run it. So it depends on how you design it, but I feel it's a good tool, so I really wanted to share that. Another nice thing of Cypress, which I want to show as well, is if I go back to my source, you can see I have another file called coverage, right? So you have a lot of coverages. You have it in JSON format. You have it like in a summary format, XML format. If you want to make sure you need to send this data and you want to manage it in some other place or some other microservice, you want to do some operation, you can always send that. But it also has a report folder. Let me open that. I open a new file and I say, oh, I'll just navigate to that coverage LCOV report, and I open this index HTML file, right? So if I open this HTML file, you can see as I have two components, content and navbar, right? So it will actually tell you the coverage, right? See, everything is covered, 100% statement, 100% branches, 100% function, 100% lines. We did cover everything. Why? Because we wrote end-to-end test cases on those components. We wrote unit test cases. We have snapshot testing. So basically everything adds up, and it will literally tell you, hey, this component is lacking test cases, and it will also tell you where it is lacking, what part is not covered. So you want to make sure you cover everything of your code as I mean, when you have a higher percentage of coverage, that's obviously right. It's better, because you'll make sure that when something changes in those covered files or blocks, it will identify at at your testing stage, when you're going to test it manually, or maybe even if you're having an automation testing on it, you can read those files. You can have indicators. So those are actually the pros of a Cypress. And let's jump into the spec. Okay, so how we can write this. So it's super easy. The documentation is really nice. They have like world-class documentation is what I would say. You can also see how it's nicely readable, right? You can know that this is visiting the website. I'm just adding weight because it's super fast, right? So I'm just waiting so you guys and I can follow what's happening along. And you can also write jQuery like, um, see, jQuery like format. So if there is a component with an ID, you can fetch it. With a class, you can fetch it. And another nice thing, what I wanted to show is that if I open back my Cypress, so let me open back Cypress. And this, okay, so there is a tool here, right? It said open selector playground. So if I navigate to this selector playground, and if I navigate to, let's say, this fab, it tells you, hey, this is the command cy.get, and you can just copy this, and then you can just go back to your code. And if you want to do something with that, right, you don't need to go and put some IDs by yourself. See how it works? And this is how it works. You can now do .then, and you can get the value as to be in a callback. So that is how easy it is. You don't really need to remember a lot of things in order to write an end-to-end test case. And for the text inputs, what I do, I just get this field by saying hash because it's an ID, Bitcoin, and I say type. See, type. So what that type is literally, this stage for me. It's typing it for me. So that is how easy it is. I wait again. I get a button instead of type. I just click because I wanna perform a click, right? A click. So that is how it works. And now this verify is super easy. I get those values. I initialize a total variable. I sum them up. Before summing them up, I need to remove the $sign and parse it into float in order to sum it up, JavaScript. And then after having my total, I expect this total and I make it to a fixed value because that is how I render it as well. And I expect this to equal whatever is inside this value. What is this value now? This value is basically the result fab. So I'm fetching this data and I put it inside the against equal what I'm trying to assert it on. And this total is what I do my own arithmetic operation in my test case. So if in your implementation at some point in time, another developer or yourself changes something, this test case will fail. And then you will see that this assert will not match anymore with whatever is inside here, right? So I hope that makes sense to you. If you have any questions with respect to the Cypress or whatever we did mocking, please feel free to unmute yourself or drop it in the message comment box or something like that. I think that's all from my side. What I had to cover. So any questions, please? I want to open it for you guys.
Yes, I've got a question.
Please.
Hold on just one sec.
Mhm.
First, I have two questions actually.
Sure. Yeah.
If I've already started coding our project and don't have any tests, what do you suggest to start with? I.e. testing modules or functions or components, or is there anything else?
See, if you already started writing production code and you don't have test cases, what I would do is I would spend some time writing the test cases. I mean, the best way of writing your test cases is in a TDD approach, right? A test-driven approach, which means that you want to make sure you write your test cases first, and then only you write your implementation code. That is the best practice. But since you already have your production code, I wouldn't say, just start afresh. That wouldn't really make a lot of sense. But you can maybe start small, right? Start writing unit test cases and make sure you cover them. Use this coverage dependency, write your unit test cases and run the coverage on it. See see how, let me open this again. See how your particular component is covered. Do I really cover everything? And if not, write extra code for that. And again, if not, write maybe an end-to-end test case for it, right? So it's never too late. I mean, as long as you realize that test cases are really important, I think that's where you will start, writing more quality code.
And touching upon test-driven development, do you think that TDD is front end or in front end has the same strength as in back end, or not?
So you mean has the same, sorry?
So the question is, do you think test-driven development is in front end has the same strength as it has in back end?
Yes, I don't see a reason why not.
Okay.
Mhm. I
Okay,
mean, when you, yes, please.
okay, so I have a question as it relates to, like, let's say could visual changes, right? So let's say I'm working on the how the site looks on a desktop, but it unintentionally affects maybe like a mobile view. Could Cypress handle like visual tests or visual changes?
Yes, it does. So if you look into the documentation, it has a lot of more functionalities than what I did today. Cypress.io, and the documentation they have is world class. So you can go over that, but it does cover those cases as well.
Great. Well, we'll give folks just another minute to think about if they have any questions. And while they're doing that, I'm just going to drop some information about us here in the chat. So I mentioned before, so this type of conversation, we're constantly looking to help folks level up how they're approaching solving business challenges with technology. So if you're looking for more of this type of content, both in terms of programs and other blog and things of that nature, please do connect with us. We have an active Slack channel, a number of other resources. Please join the community and join the conversation to drive more conversations like this. Check out the link that I just shared in the chat. And again, does anybody have any other questions while we've got the expert Shiva with us?
I also dropped my GitHub a project link. So if you want, if you need access to this project, if you want to play around with it and try it yourself, you can always clone it. And if you have some free time and you want to improve it, you can always fork it and create open PRs, and we can always improve it more.
All right. Well, I want to thank Jacob and I want to thank everyone for coming out tonight. Shiva, you were amazing once again. So we'd appreciate all your insight and knowledge and your continued help in building our community. Everyone else, thanks so much for coming out tonight. The Collider team really appreciates your presence. Be on the lookout. Deshaun, Enrique, you're very welcome. And we hope to see you in future programs. And yeah, awesome job again, Shiva. Jacob, is there anything else you want to add, or are we good to go?
Everybody give it up for Shiva. Give it up for Shiva.
Thank you very much.